All right, let's check this assignment to make sure you are ready for our quiz. So, a couple things. Here we go. We first put this information in, and there's the slope, y-intercept, r squared. Make sure you're getting, you know the difference between r squared and r. Also, I think on the quiz, FYI, I don't even say r squared and r. I say coefficient of determination for r squared, okay? And of determination. And then I say the correlation coefficient for R. So make sure that you know the vocabulary that goes with those. Remember, the correlation coefficient is represented by the R. So there you know that that's what that is. Okay, there's our explanatory and response variables. So here was our predicted murder rate. You have to have the prediction hat. No partial credit. It's wrong. Predicted is different than actual. All right. We were talking about the number of registered weapons. So, notice, okay, context of, let's see, the units matters. So this was for every increase in 1,000 automatic weapons registered, okay, because this was the automatic weapons registered in thousands, okay. Then the murder rate is, the murder rate is predicted to increase 0.85 per 100,000 people. Okay, I guess I didn't put that in there. So what interpret the y-intercept? It happens when the x is 0, when there is no additional automatic registration of automatic weapons. Their murder rate is still predicted to be 4.05 per 100,000. I guess that's how many murders will happen on average per 100,000. Okay. Now, remember that this will now be asked to describe the relationship. No longer do you get this question about doing the interpret the correlation coefficient right here. So F will no longer be read as that. Okay? No longer interpret the value of the correlation coefficient. It'll say, describe the relationship. And there it is. Next, so there is a strong positive linear relationship between those two context X and Y's. About 78% interpret the correlation coefficient of determination. About 78% of the variability or the fluctuation in murder rate can be explained by the varying numbers of the automatic weapons registered. Make sure you have those fluctuation words in there. Okay, next, here we go. This one was E, okay, because there's basically this is pretty much saying the slope of the equation, which then transforms to this. The thing I don't like about it is it doesn't talk about the predicted increase, so that's kind of a weakness there, but otherwise it was the best one. Here, our predicted SAT was 12,907 because we had our slope and our y-intercept. All right. Suppose the correlation is negative. So I just kind of drew something so this red line with the blue dots is the correlation to something that's negative. So I just kind of put those all on there, and then I went and looked at these statements to see which of them can be true. And all of them could happen because the question is which is possible. Okay, so all of these, and I have examples here of they all being able to be true. Here, you can't have a correlation or correlation coefficient of 1.15. R is between -1 and +1, so it can't be greater. He made an error in arithmetic. Here we go. So what should happen is when you are reading this, you hear about the percent of variation in the GPAs, that it can be explained by looking at the SAT score. So just hearing that language is supposed to kind of jog your memory in thinking that that's asking about an R squared. So therefore, I went and I just took this 0.632, and I squared it, and I got the 0.3994. So that's how I knew it was answer C. So again, you've got to know those definitions so well that you're just kind of recognizing the language of them. Here, the mean is always 0. That is true. The mean of the residuals is always 0 because the sum, the positives and the negatives, sum to 0. So there you go. That means the mean is also 0. And then those both were true, all three of them true statements. All right, here, the 1 and 2 were true, but the third one, I was like wanting to double check this one. I know I looked it up on the internet. I actually just typed it in to go see if I could find the answer for this one. And so what the deal is that this correlation of 0.75 is telling me it is stronger. Okay, we do have a stronger linear relationship, but it's not necessarily saying that it is 3 times as strong as one that is only 0.25. Okay, so that's where this misnomer is and the problem with that. Yes, it's stronger, but not necessarily this like quantitative 3 times as strong. Okay, 9. You can hopefully line those up. A went with residual B. B went with residual C. C went with residual A. 10. Okay, you've just got to be able to put these lines in here, the line of best fits, the LSRL, and then C, you're thinking backwards. Here's the accentuated residual plot with this line down the middle. So here is how that looks with those dots going below and then back above. Here, I went ahead and I looked at these example things to see. One is true because look, here I can tell I had 2 that made 100 on the midterm. Here I had 2 that made 100 on the final exam. So statement 1 is true, same number. Students who scored higher on the midterm generally did lower on the final because, see, that's that negative. As X is increasing, the Y is decreasing. That's that negative relationship. So then a moderate negative is true. All right, and moving on. Here is what's happening with this one. There are 2 of them that are 0 and 1 of them that's close to 1. Okay, because these pretty much, now they've got some kind of something happening, but they are going to not give me much linear correlation. They're just kind of looking like that. So there are 2 of them are 0 and the other's closer to 1. All right, look at that curved pattern in the residual plot. If a pattern is what you see, then you must say, yikes, the data's not a line, no line. So that was not that way. Here, I just plugged in 20. X is 20. They tell me the actual is 25. So I plugged 20 in to get the predicted Y is 29.6. Therefore, residual RAP, residual R equals actual Y minus predicted Y. That's negative 4.6. Next, number 15. Oh, this one's a good one. Man, you got to know this stuff here. So I made this problem just for this page because I wanted you to experience this kind of a problem. So here we have this regression line in this equation, okay, predicting the height. So this is a residual plot, okay? Do you see this? Here's the 0 line. Okay, so that's the residual line of 0. Is a linear model appropriate? And your answer is yes, because there is no pattern in the residual plot. All right, now predicted at 55 days old. So the predicted at 55 days old is 21.2. All right, but now, what is the actual height of the sunflower in the sample above? Well, you have to look up here. Look at this. Here is a 55-day-old sunflower, and it is actually about 1.9 inches above what it was predicted to be. Remember, this right here is your prediction line. So here's what it was predicted to be, at which is what? 21 point, what did it say? What did we figure out? 21.2. So this represents 21.2 height. Well, the actual is about 1.9 above that. So that's how I can say what the actual is, the key to this problem is finding the residual in the graph above. So there you go. So 21.0, oopsie, 21.2. So that should be a 2 there. So it's, anyway, there you go. It's about 22.9 or 23. I didn't put that correctly. Okay. Predict the height for a sunflower that's 45. Plug 45 into the prediction equation. That's 16.2. And now, same thing. Look at the actual height of the sunflower in the sample above that is 45 days old. Here's what was predicted, and the actual was about what, 1.4 or 1.3, somewhere approximately that, 1.3 or 1.4 inches lower than predicted. So if 16.2 or whatever is what was predicted, then you got to go 1.3 lower than that, and that's at about 14.9, somewhere around there. Okay, so hey, you want to predict a sunflower plant that is 120 days old? No, this is only going until 70 days. Predicting out here at 120 is dangerous because you do not know if that function is going to continue to be linear out there in the future that far. So that's a no-no. You cannot predict that far out in the future. That's extrapolation. Plus, because I don't even think the plant lives that long. In fact, the plant I did look it up in hindsight. They only live about 2 weeks. So this was kind of like not really appropriate for sunflowers, but we'll just pretend it was. Next, number 16. For every increase in the temperature, so you had to identify. You have to make sure when you read a problem like this that you are identifying what is X and what is Y. I usually like to identify what's X and Y, write out my statement of what I think that the slope is, and then kind of go find it. Because it's too tempting to want to just read through those and then miss the correct answer or make a mistake. All right, here's a great AP question, 2011. Here we have this. Interpret the slope. Was this problem's first question, interpret the slope. For every one, it was number 6, so it's the first part of problem 6. For every 1 foot increase in the width of the grass strip, the amount of nitrogen removed from runoff is predicted to increase 3.6 parts. You either have the word predicted or you say it increases about 3.6 parts. Predicted or about, but not both. Predicted or about, but don't say both. All right, how about this? You're going to feel comfortable making a prediction between 0 feet and 30 feet? Look, this is data for 5 to 15 feet. So 0 to 5, I don't know what that's going to have, what kind of results those are going to have. And I certainly don't know 15 to 30 what those results are going to have. That's far outside the function that I'm confident in predicting in. I'm only confident in predicting from 5 to 15. So therefore, that's extrapolation. No, I would not feel comfortable predicting out in those farther areas. All right. And then that next part is tomorrow's notes. So there you go. There's your warm up and your extra practice. And so good luck on your quiz.